Okay, so today's lesson is about rational functions. So last year, your teacher may have skipped graphing them because we were in quarantine by that part. She should not have skipped, or he should not have skipped the chapter over rational functions in Algebra 2 that had like x's in both numerator or denominator, where we had to like factor and cancel stuff or add these together, divide them or multiply, functions that look like that. But it's the graphing that they may or may not have skipped. I know for my class, we did bare minimum. So at the very beginning of the year, we went over an equation that looked like this: y equals 1 over x. And I called this the reciprocal function. Do you guys remember anything about y equals 1 over x? Does anybody remember anything about it? I'm just going to sketch a quick graph. Does anybody remember anything about it? Do you remember something? What did you say, John? Kind of. Is there anything you can share with me, or is it secretive? Yeah, there's like 2 branches. There were branches. They were kind of curvy. How did we get the points for it? That was close to when we did this. You're thinking of inverses. You're thinking of inverses. And technically, this does reflect in that y equals x line, but that it won't be the case for all of these. Okay, so if you're not sure, I'll tell you, to get the points, we made a table and we picked x's. And why do I call it the reciprocal function? Reciprocal what? It's like switched over, like switched like that. That's inverse. So it's not switched like that. It's switched a different way. What do reciprocals do? Switch like this. So if I put -2 into 1 over x, if I put -2 in, then I get -1/2. And that's the reciprocal of -2. The definition of a reciprocal would be to do 1 over whatever that number is. So if I put in the number -1, I would get the reciprocal, which is still -1. If I put in the number -1/2, and that was one that I used when we did these, then we reciprocate that. And what's the reciprocal of -1/2? -2. If I put in 0, what's the reciprocal of 0? It is undefined. And because we had that undefined, we went over the word asymptote. At x equals 0, there is an asymptote. So on my graph at x equals 0, I'm just taking another color so I can see it. I have an asymptote. That means the graph is not going to cross through that. Means the graph is going to get closer and closer and closer to that line, but not past it. And then, let's see, I kept going. I did +1/2. I did +1. I did +2. And those would be 2, 1, and then 1/2. And then there was one more thing about this before I plot these that we talked about, was how could we possibly have 0 in the y column? What would I put in for x that would give me 0 in the y column? That means 1 over x has to equal 0. What could I plug in for x to make that true? I can't really plug in undefined because it's undefined. So really the answer is there isn't anything you could plug in. And yes, it has to do with being undefined. Let me write that. It's fine. So we have another asymptote here. I didn't write this asymptote up here. This asymptote was x equals 0. We have an asymptote also at y equals 0. So on my graph, there is a y equals 0 asymptote. So then we take our points and we graph them. So -2, -0.5, -1, -1, -0.5, -2. And then if you were unsure, and I'm pretty sure we probably did this the first time, if you were unsure, you could always plot more points in your table. But this is what it looks like. It looks like a little curve. It's getting closer and closer to your x and y axes, but never passing through. Okay, and that was our reciprocal function. Now, reciprocal functions and other functions that we're about to do are called rational. And the word rational has a word in it. Ratio. And what does ratio mean? Fraction. Good. So all of these functions have fractions, and I don't mean just like 1/2 in it. I mean like an x is at the bottom. All of these functions have fractions. Not all of them are going to look like this one. That was one that we started out with in chapter 1 because we were looking at all different kinds of functions in general. So not all of them will look like that, but some will. Now, another thing that I want to talk about before we look at our notes is just dividing, or actually maybe just asymptotes in general. Let's talk about asymptotes. So here's one major way that we can find asymptotes is the denominator cannot equal 0. So if I have f of x, and I'm making this up, 5x squared minus 2 over x plus 3 times x minus 9, where could we possibly have an asymptote? The denominator cannot equal 0. I hear you. So if I say x plus 3 is equal to 0, and I solve that for x, I get x equals -3. So if x equals -3, that makes the denominator equal to 0, and we can't have that happen. So this would be an asymptote. And about that same way, x minus 9, if that equals 0, then the denominator equals 0. So if x equals 9, the denominator equals 0. We've got 2 asymptotes. At least 2. I should say at least 2 asymptotes. There are other asymptotes that I haven't showed you yet. These would be vertical asymptotes. These would be vertical asymptotes. The graphs will never, ever, ever, ever pass through a vertical asymptote. Never, ever, 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 ever pass through a vertical asymptote. So once I'm not going to graph this whole thing, but if I have a graph and I've got x equals 9, and I've got x equals -3, the graph will not pass through those borders. It will not pass through those walls. There is a vertical asymptote for this, which I will show you how to find, but I'm just going to tell you what it is right now. There is a vertical asymptote for this. Again, I'm not going to explain it till we get to that spot, but not vertical. Am I saying vertical? I meant horizontal. The other way. There is a horizontal asymptote for this. It's going to be at y equals 5. And for this, a graph may pass through a horizontal asymptote. It might. The horizontal asymptotes are meant for the end behavior of the graph. So at the very ends of the graph, it will have this horizontal asymptote of y equals 5. I don't know if it's going to be below the graph or above the graph, but it'll be getting closer and closer to 5, just at the very ends. But stuff could still happen in the middle. And this is one part that people just have trouble just understanding. So I want to get that out right now. And I will show you how to find the horizontal asymptotes. They're easy to find. And then for this section, oh, that does not good spelling. There we go. For this section, we're going to be doing some long division, not much. We're going to be doing some factoring. What else is coming up? Domain and range. In interval notation. Finding x and y intercepts. Possible, we might do transformations a little bit, which we did at the beginning of the year. And then the last thing is we're going to use our graphing calculator. Okay. So I'm ready to move on to the notes whenever you guys are ready. I just didn't feel like I had enough space in the notes to go over a lot of this up here. Just kind of show you the graphs. These graphs are going to look fun. Oh, by the way, one more thing before we go there. The number, I'll put it right over here. The number of vertical asymptotes breaks apart the graph into separate branches. You must graph all branches. The number of vertical asymptotes, that's going to tell you how many branches we have. If we have one vertical asymptote, like the one right above it, if we have one vertical asymptote, that's going to break the the graph into two separate branches. If your graph is set up where that vertical asymptote is at like -10, and I can only see half of the graph, then you need to change your scale. So this second example that I did down here, how many separate pieces are there going to be for this graph? It's going to be 3. There will be one piece somewhere in here. There will be a second piece somewhere in here. And there will be a third piece in here somewhere. And this is kind of like when we did piecewise functions, how we had the pieces in those certain borders. It's a lot like it, only this is not a piecewise, this is one function. Okay, let's do the notes. So we're going to start with talking about asymptotes. Now this is what a rational function looks like with all just variables, and it looks incredibly confusing. But really, it's like having a function on top of another function. Both the top and the bottom have x's in it. It's a function on top of another function. So they're calling the top function numerator of x, n of x, and they're calling the bottom function d of x. And those are the functions. N of x and d of x have no common factors. That means if you can factor and cancel common factors, you do that. Okay, because they have no common factors. So if we can factor it and then cancel common factors, then we're going to do that. So it's kind of like the simplified version of that. To determine if there are horizontal asymptotes, it's going to have to do with the degree of n of x and d of x, which we'll get there. So this is how you tell, and then I'll kind of tell you how I can help you try to remember. Okay. So this says if n is less than m, then we have a horizontal asymptote at y equals 0. So I'm going to show you what that looks like. I'm going to zoom in. Okay, so this is just a really simplified version. It won't always just be x to the 5th or something on top. There's usually other stuff going on with it, but all you're going to look at is the degree. And remember, to get that degree, you just use that first exponent. If it's in standard form, you use first exponent. So the degree would be n, and then the degree of the bottom is m. And this says if n is less than m. So the degree on top is smaller. And y equals 0 is your horizontal asymptote. The second example would be if n equals m. If they are the exact same, then what you do is you take, let me make a new example here. Same kind of example. I've got a function on top. I've got a function on the bottom. And here it's telling us that n equals m. The degrees are the same. To find the horizontal asymptote, y equals, you just put their coefficients on top of each other, a over b. Just put the coefficients on top of each other, and then we get the horizontal asymptote. And then your third example, if n is greater than m, there is no horizontal asymptote. If n is greater than m, there is no horizontal asymptote. So we only have a horizontal asymptote in two different scenarios. Other than that, there isn't one. But there is something called a slant asymptote. If we have choice C, if there is no horizontal asymptote, then we're going to go look for a slant asymptote. If there is a horizontal, you don't have to do this thing. If there is no horizontal, we're going to look for a slant asymptote instead. Or it could also be called oblique. So to do that, you're going to use long division. Right? No, wait. Yeah, divide it. Sorry. I was self-doubting myself for a second. X plus 1, and then x squared minus x plus 0. We got to plug in the 0. We're going to do long division. So x goes into x squared. X times, we're going to distribute that, x squared plus x. Then we're going to draw the line. Change, wrong color. Change the signs. Add, I get negative 2x plus 0. Yes, dear.
Since it's x plus 1, can you do the synthetic division?
Yeah.
All right.
I'm trying to think why I don't. I'm trying to remember back in time why I don't, but I'm going to keep going and finish this one. Okay, and then x would go into negative 2x minus 2 times. And then from there, we'll distribute. And I'm writing over the words that are there. Sorry. Negative 2x minus 2. Draw the line, change the signs, and we would get 2 for our remainder. I guess I left this big empty space to do the division on. Oops. Yes. Maybe. Where were you looking, hon? I don't know where you... Did I mess up or did I not? Connor, I didn't mess up?
No.
Okay. Okay, I'm sorry. It's very possible that I make a mistake because I do that every other minute. Okay, I'm going to say right now you will never use the remainder. Okay. And for this, oh, I skipped over something. For this, our slant asymptote is going to be y equals x minus 2. It's going to be y equals x minus 2. That's going to be your slant asymptote. There's one thing that I skipped over that I'm going to go back and highlight now. We're only going to look for a slant asymptote if the numerator, the degree of the numerator is exactly 1 more than the degree of the denominator. It's the only time we're going to look for that, because when I divide those, I will get a line. If it's a different scenario and I divide those, then I'm not going to get a line. So those are the only times I'm going to divide it. If the top degree is one more than the bottom degree, then we will have the difference of a line. And that will be a slant asymptote. So for like what y equals x minus 2, we'll have at negative 2, oh geez, negative 2, and then up 1 over 1, up 1 over 1, and so on. That's going to be just an asymptote where the graph is going to get closer and closer to that, but not pass over it. And then what is our vertical asymptote for this same question? For the vertical asymptote, the denominator cannot equal 0. What's our vertical asymptote? X equals negative 1. So here there's a negative 1 asymptote. And you'll see our asymptotes form kind of like an X. And I have not graphed this one. And if I did, it was so long ago, I don't remember. But so I'm totally like making this up right now. The graph might look something like this, where it kind of has those branches, but they're kind of not 45 or they're not 90 degrees or in between other angles. Okay, so we are going to find and plot the y-intercept. We're going to do that together. And we always do that by plugging in 0 for x. That's nothing new. We're going to find zeros. Zeros would be by making the equation equal to 0 and solve for x. We're going to look for any zeros in just the denominator because that would be vertical asymptotes. We're going to find if there's any horizontal asymptotes or maybe a slant asymptote. We're not going to test for symmetry. I didn't teach that to you this year. We're going to plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. And we're going to use smooth curves to complete the graph between and beyond the vertical asymptotes. So here's what we're going to do in order. Okay. Occasionally, there will be a hole in the graph. I'll show you a picture. I'll just draw a line because you could have a line with a hole. Occasionally, you could have a graph that has a hole. If you graph it on your graphing calculator, you will not be able to see the hole. If you graph it on Desmos, you will not be able to see the hole. Your calculator Desmos won't put a dot, but you're going to put a dot so when you graph it, everybody knows there's a hole there. A hole you would get if your original function factors and cancels common factors. If your original function factors and then from that factors cancel, you will have a hole. How to find the hole? Okay, I gotta zoom in. My handwriting's terrible when it's this far out. We're going to set the factor that canceled equal to 0 and solve for x. In the reduced function, plug in that x and solve for y. This is an ordered pair. This point is not in the domain or range. So I'm going to go back to Algebra 2 when you guys learned Algebra 2 last year. I can't go back yet. Are you guys still writing down? Sorry, I'll give you another second. So once you cancel those factors that can be canceled, you're going to set that factor equal to 0. You're going to solve that x. Once you get that x value, you're going to plug it in to solve for y. That's an ordered pair that is a whole. And then from there, when you go to find the domain and range, you have to keep in mind that whole cannot be in the domain and range. So going back to Algebra 2 for a moment, let's see. I'm going to try to make up an easy one. Let's say we factored something and we got x plus 3 times x minus 2 over x minus 2. You factored it. What did you do in Algebra 2? Next. What do we do, Lydia? Okay, we went, right? We canceled those out. As long as it's factored, we can cancel it. And then we had x plus 3. But that should not have been the only thing you wrote there. There was kind of like a comma and some more information that we wrote to make these expressions completely equivalent. Do you remember, Nick? You were shaking your head like you remembered. So are these expressions completely equivalent? They're not, because what happens if I plug in x equals 2 into this equation? Well, we know it's a whole, but like let's say I typed in that equation into the calculator and I put 2 in for all my x's. I didn't even do 2 minus 2 on the bottom. I just put 2 minus 2. What would happen on my calculator? What would happen, Lydia? It would tell you there's an error. It would even say divisible by 0 or divide by 0 or something like that. It would tell you there's an error because here x equals 2 does not work in this equation. But what if I plugged x equals 2 into this equation? Would it give me the same error? It would not. So these are different equations. So to make them exactly the same, you say off to the side, but x can't equal 2. That's what you did last year in Algebra 2. Hopefully. I wasn't there, but I know my students did. Okay. And that x minus 2, or sorry, that the x minus 2, the x equals 2, that is part of the whole. And that's where this is all coming from. Last year we were reducing it, but we weren't actually just graphing every single one. Okay. How many people do not remember doing this? I'm just curious, just out of curious. It's fine, you're being honest. We did it though. But it was in quarantine, so you're right. I don't know how much you did. I don't know how much any of you do. So many people do not remember. Sorry, I'm not going to yell at anybody else, just Chris, because he had me. And we got that out of the way. Everybody else in this whole room remembers doing x does not equal 2 except for Chris. Yeah, I don't think they're being honest. Okay, great. You guys should be good then. All right, so that's the whole. What else do we have here? Vertical asymptote. We kind of went over this already. Vertical asymptote. What's it? How to recognize there is one. If there is an x in the denominator. If there's an x in the denominator, there will be a vertical asymptote. And that's after you canceled factors. Common factors. And then how to find it? Set denominator equal to 0 and solve for x. So if there's an x in the denominator, you will have a vertical asymptote. When you set the denominator by itself equal to 0, solve for x, you will find any vertical asymptote. Horizontal asymptote. How would we know there is one? If the degree of the numerator is less than the degree of the denominator, or if the degree of the numerator is equal to the degree of the denominator, we will have a horizontal asymptote. If the degree of the top is smaller, or if the degree of the top is equal to the degree of the bottom. And then how would we find it? For the first option, then y equals 0, that's it, I found it. The second option is we divide the coefficients, let's forget an F, of the numerator over the denominator. And then that's what y equals that. It's as easy as that. And then the last thing is, yeah, oopsies, maybe. Is that far enough? Okay, and the last thing is slant asymptote. That would be if the degree of the numerator is exactly 1 more than the degree of the denominator. And then you would use division to find the line. Do not use the remainder. And the 3 things at the bottom say you can have horizontal and vertical asymptotes and holes. You can have vertical and slant asymptotes and holes. You cannot have slant and horizontal, which I had talked about that already. Just reminders. Okay, I think this is kind of just repeating everything that we've said. But if you want to use this as a step-by-step, it's helpful. I'm just going to do the step-by-step. Okay, so example 1. We're going to go through, basically go through these steps and fill everything out. And it might not be in the order, it might not be listed in the order of which we're going to actually find everything. So the first thing that I'm going to do is I'm going to look at the equation to see if I can factor anything. So that's the first thing I'm going to do. And you can't tell that by looking here at all the choices. But the first thing I'm going to do is see if I can factor. Can I factor? What can I factor? I can
factor out x.
Out of what? So factor, I'm going to factor something out of this entire numerator, or I'm going to factor something out of this entire denominator, not out of one term. So is there something that I can take out of 2x and 1? And x and 1? No. And they are both linear. They're not x squareds. They're both linear. So they are both just simplified factors. They're already factored all the way. These are factors. We can't factor them further. So that is a no. I'm going to move on. I'm going to look at my domain, and my domain has to do with, oh, actually, so I'm not going to have a hole. Because I'm only going to have a hole if I can factor and cancel something. I couldn't do that. The domain has to do with holes and vertical asymptotes. Domain are the x's. It's going to do with holes and vertical asymptotes. Where's my range? I don't know why my range isn't in here. Okay. So I'm going to look at the denominator, and I'm going to say x minus 1 equals 0. So if x equals what number? If x equals 1, that makes the denominator 0, and that means the graph would not be there. So vertical asymptotes, I've got x equals 1. Go over my graph. I'm going to graph that. That also tells me that my domain is only missing the number 1. So my domain is going to go from negative infinity to 1. It does not include 1. But then it's going to go from 1 to positive infinity. Horizontal asymptotes are next. And we're going to look at just the degree of the top and the bottom. For horizontal asymptotes, I've got a 2x and I've got an x. I'm just looking at the degree. What do we know about these degrees? They're the same. So if they're the same, we divide the coefficients. So that gives me 2 over 1. Y equals 2. Yes?
On the domain,
Mm-hmm.
around the ones, don't we have to use like the other kind of bracket?
So it's not going to equal 1. So it's going to be a parenthesis for this. Okay, the other bracket would mean it does equal 1, but it can't. Okay. Thank you for asking. Slant asymptotes. If it has a horizontal, it won't have a slant. So I can just be like, none, and move on. So the x-intercepts would be when the equation equals 0, 2x plus 1 over x minus 1. Zoom in here. So the x-intercepts would make the equation equal 0. If I put this side over 1 and I cross multiply, then I get 2x plus 1 equals 0. And this will happen every single time if you cross multiply this. So if you want a shortcut, it's really just the numerator that you have to solve for. But if you forget that, rules for always finding x-intercepts is set the equation equal to 0 and solve it. So what makes this true? When x is negative 1/2, the x-intercept would be negative 1/2. 0. And I'll plot that in a second. I'm just going to stay zoomed out for another moment. For the y-intercept, we plug in 0 for x. So we do 0 or 2 times 0 plus 1, and we do 0 minus 1, and we simplify that. And I get -1 for my y-intercept. All right, so I got my asymptotes graphed. My x-intercept is -0.5, 0. And 0, -1 is the y-intercept. So somewhere around here it said how to find where you should find points. I think it was on this side. So it's plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. One point between and 1 point beyond each x-intercept and and vertical asymptote. So it suggests that I go beyond, like this side of my x-intercept, and it suggests I go on this side of my vertical asymptote. Okay, so you always plug x's in. So let's plug in an x that is to the left of -0.5, and that is to the right of 1. You can plug in whatever you want. Maybe a few people will pick different things. Everybody pick their own. Pick, and there's additional points you can fill in. Pick a number that is to the left of -0.5, and pick a number that is to the right of 1. We're just going to team this here. Pick whatever you want. So I picked -3 and +3. And this is what I got. Now, I know that the asymptotes are there to guide my graph, so I feel like I can probably graph the bottom corner. The top corner, I feel like I might need another point just to make sure I'm doing it right. Did anybody pick another number for the top corner other than 3? I picked 3. Did anybody pick a different one? 2? What'd you get? Did it work out perfect? Guess I should have picked 2. Did anybody pick a different one? So 2? What'd you pick?
5.
What'd you get?
11 over 4.
Okay, so 2, 5. And I'm guessing you guys are right. I'm not going to check it. And did you get a different one?
I did -1. I got 1.
Looks about right. And then oh, I forgot which one you said. You said 5, no, 5, 11/4. What is that? Almost 3. Okay, so once I have a few more points, then I can see that it is making one of those branches that I'm somewhat familiar with. So you don't need a ton of points, and it doesn't have to be 100% perfectly accurate. Okay. All right, let's try another one. So the first thing is not written down, but you have to remember it. First thing we're going to do is factor if possible. And this one, I'm thinking it will probably be able to factor it. So take a moment, see if you can factor it. Did it factor? Any points or any factors cancel? No. Okay. So there's no holes. Domain, that has to do with the denominator. So since it is in factored form, we're going to set the denominator equal to 0. And since it's in factored form, this is pretty easy for me to find vertical asymptotes and what is not in the domain. At x equals -2 and at x equals +2, we'll have 2 asymptotes, vertical asymptotes. And for our domain, it'll start at -∞. It will go to -2, union -2 to 2, union 2 to +∞. It's not going to equal those because those numbers are in they're asymptotes, so it'll never equal those. So that's why we have the parentheses. So for this graph, we've got 2 vertical asymptotes. So we're going to have 3 separate branches. 3 separate branches. Now we look at the horizontal asymptotes. And the horizontal asymptotes are going to come from looking at the degree of each. So if I'm looking at the degree of the original, it's going to be a lot easier than looking at the degree of the factored. But let's say I am looking at the degree of the factored. We would have to multiply those x's back together to see there's 2 x's here. And at the bottom, there's 2 x's there. So our degrees are equal. So what do? So we divide the coefficients. And it's just going to be 1/1. So y equals 1. If there's a horizontal asymptote, there are no slant asymptotes. To find the x-intercepts, we make the entire equation equal to 0. And since it's already factored, I'm going to choose the factored version. That's going to help me solve for x quicker. So I'm going to make this entire equation equal to 0. When I cross multiply that, I'm really only setting the numerator, x minus 3 and x plus 1 equal to 0. I'm just going to do it down here. So it's factored. I can set each factor equal to 0. And I will have x-intercepts at -1, 0, and 3, 0. Notice how I put them in order. My y-intercept, I plug in 0 for the entire equation for all the x's. For this one, I'm actually going to choose the original question to put 0 in. I think it's easier in the original one. For x equals 0, I'm going to put in the original one. I got to zoom out, though. I can't see it all at the same time. So I'll have 0 squared minus 2 times 0 minus 3 over 0 squared minus 4. So I get -3 over -4, which is 3/4. You can plug it into the factored version. I'm just going to do what I think is the least amount of work. So go ahead and plot my 3/4. And I'll plot my -1 and my 3 for the x-intercepts. So the the vertical asymptotes are the end behavior. They're the end behavior for the graph. So this blue horizontal asymptote, I know that this is going to get closer and closer and closer to it because it's the end behavior. But in the middle, it won't necessarily use that. It might, but it might not. And then on the end, it's going to use that, but I don't know if it's going to be above it or below it. So we'll definitely have to find a point in this outside section. Pick any number from -2, bigger than -2. And then on the inside section, we should probably pick a point that is, I don't know, 1. That's like the most obvious one that I just thought of. Should probably pick 1 to try for that middle section. This one will probably go down too. So what I say, we're going to definitely choose 1. Somebody yell out a number you're choosing that's left of -2. Yell at a number, just the number. Say it louder. -4. What else are you guys choosing? -6. Anybody else? -3. Okay. Lydia, did you find -4? Okay. Everybody find theirs? Nick, what'd you do? -3? What'd you get? Okay. We'll see. Who else got 12/5? Maybe they can. Okay, good. Anybody get -4? Not yet. Caleb, what'd you do?
I did 1.
Oh, what'd you get for 1? 4/3. Good. Anybody do -6 yet? John, what are you figuring out?
I did -3. I got 12.
Everybody did -3. All right, I'm waiting for these answers. When you get them, yell them out, please. I'm going to graph the 2 that you guys gave me. 1 is 4/3. And 2 and all right, who was my -6? Is that Brandon? Or you were -3? Who was my -6? Oh, that was Connor. What'd you get? A really big number. It's kind of big on top and bottom. 45 over 32. A little over 1, but not quite 2. Closest to 1.5. About there. Doesn't have to be perfect. All right, and who was my other person? Lydia, did you get an answer yet? 7/4. Looks about right. Okay, the asymptotes, the vertical asymptotes, all pieces of the graph will use those. But the horizontal asymptotes, those are mainly for the end behavior. And do you see what happens in the center now? We could find more points if we need it. But what's happening in the center is that this is using the vertical asymptotes, but not necessarily the horizontal asymptote. Because the horizontal asymptotes are reserved for the end behavior. You guys see that? Okay, I think we have one more, just one, or we have 2 more, sorry. We've got lots of time, that's good. Okay, next one, our first step. What should we do for our first step? Okay, factor. If I'm slow, which I know I'm slow because I'm waiting for everybody, work ahead. See where you're going to have questions. Work ahead. I'm making a video that, you know, I want to make sure that anybody who's not here would be able to get it too. Okay, we should be able to factor it. Top would be an x minus 3 and an x plus 2. The denominator would be an x plus 2 and an x plus 1. What can happen? Right. So we can cancel out the x plus 2s, but we're not going to just forget about those x plus 2s forever and ever, ever. They are going to come back. So we canceled out the x plus 2. I'm just put that over there for a moment. I'm going to come back to that. So after I cancel out the x plus 2, my new function is x minus 3 over x plus 1. If we cancel out the x plus 2, there will be a hole. The x value of that hole is -2. A hole is an ordered pair. So to find the y, I have to plug in -2 into my canceled simplified equation. So I'm going to plug in x equals -2 into the equation. I'll have -2 minus 3 over -2 plus 1. So -5 over -1. So I get 5. So my hole is at -2, 5. I'm going to go over to my graph and just make a hole so I don't forget about it. I think some people tend to forget. So from algebra 2, when you canceled those x plus 2s, you would at the end would write x does not equal -2. That's what we did in algebra 2. That's going to affect our domain. So our domain and our vertical asymptote at this point, we're going to set x plus 1 equals 0 and find out that we have a vertical asymptote at -1. And so our domain is going to start at negative infinity. And we're going to go all the way until we get to -2, and it's going to skip over -2. Then we're going to start at -2 again, and we're going to go to -1 while it skips over -1. Then we're going to start at -1 and go to positive infinity. So that hole and that asymptote are both places not in the domain. Stop. Horizontal asymptotes. We're using the same rules as before. I'm looking at the top and the bottom. Our horizontal asymptotes, I have the same degree. So I'm going to put the coefficients on top of each other. What is my horizontal asymptote? 1. Okay. So because there's a horizontal, there is no slant. To find the x-intercepts, I'm going to use the simplified equation, not the original. I'm going to use the simplified equation. And so my x-intercepts, I'm going to set x minus 3 equal to 0, the top. X-intercept at 3, 0. The y-intercepts, we will take the simplified version, the x minus 3 over x plus 1, and plug in 0 for x. And I will get -3. All right, who can plug in x equals -3? Say me. I'm going to do it. Who's going to do it? All right, somebody said it. How about -4? Okay, a couple of people are doing that one. Do that one. Who can plug in x equals 1? Somebody's going to plug in x equals 1. Call it. Say me. John, say me. Who can plug in x equals 1, 2, 3, 4, 5? Who can do 5? Are you doing more than 1? Just do 1. There's like 20 of us in here. Nairi's doing it. Y'all better pick one and do it. I'm just randomly choosing ones that would be good to choose. I don't remember what I said now. What did I say? -3, -4. If you chose another one, you can yell out your answer too. Did you get one?
Yes.
What'd you do?
-3 is 3.
It's just 3? That's nice. Who did -4? Come on, like 2 people raised their hand for that one. Chris, aren't you doing -4?
Yeah, I got
7/3. Anybody else get 7/3? I'm not checking answers here. I'm believing you guys. So 7/3 would be, yeah, it doesn't look right. Yes, it does. Never mind. I'm thinking the wrong way. 1, 2, 3, 4. About there. Okay, I think I know what's happening on the left side. We've got 2 asymptotes.
There's 7/3 in space wrong. It should be
2 and a, my bad. I don't know why I was thinking. I was struggling with that one apparently. Okay. On the left side, it does appear to be curving around. So I think we probably have enough information to draw this getting closer and closer to the asymptotes. On the right side, who did 1? Oh, Lena, what'd you get? Okay. And who did 5? What'd you get? So 1, -1 looks right. 5, 1, 2, 3, 4, 5, 2/3. That looks about right. Regardless of what points you choose, they should still all be on this curve. Oops, getting closer and closer to the asymptotes. So this is an example of one with a hole. All right, what haven't we had an example of? Yeah, let's see if that one does it. What should we do first? Factor. So I factored it to x minus 3 and x plus 2, but none of my factors cancel. That's okay. Having the factors there is helpful in the long run for solving the other things. So there's going to be no holes. I can go ahead and say none. My vertical asymptote is going to come from the denominator. X plus 1 equals 0. So we have x equals negative 1 for our asymptote, vertical asymptote. And then that's also going to help determine our domain. We're going to go from negative infinity to negative 1, union, negative 1 to infinity. All right, horizontal asymptotes. We're going to look at the degree of the top and the bottom. Are they the same? Because all the other ones we did so far were the same. No. So our choices are the numerator is less than the denominator or the numerator is greater than the denominator. If we have less than, then y equals 0 will be our vertical. We don't have less than. We have greater than. So that tells me there is none for horizontal. So now we check for slant. For slant, it would be like our numerator degree is equal to our denominator degree plus 1. If I take my denominator and I add 1, will it have the numerator degree? 2 is equal to 1 plus 1, right? So we've got that case where the top is exactly 1 more than the bottom one. So we're going to divide. I don't know, I can't copy it right. So x goes in x squared, x times, I get x squared minus plus 1. Draw the line, change the signs. I can't. I don't know why I'm failing right now. And then x goes into negative 2x minus 2 times. And then that's as far as I need to go because the denominator or the remainder doesn't matter. I just have to get to x minus 2. My slant is y equals x minus 2. So I'm going to go to negative 2, and I'm going to use my slope. And this is a slant. X-intercepts, we can just make the numerator x minus 3, x plus 2 equal to 0. So I get x-intercepts at negative 2, 0, and 3, 0. And then my y-intercept, got to plug in. Well, I was going to plug it in the original before it was factored. It's easier for me to find the y-intercept that way. So my y-intercept, if I plug it in the original, then all those x's become 0, and I get negative 6 over positive 1. How many separate branches will we have for this one? How many separate pieces will we have? Who remembers what I said about that earlier in the notes? Are you guys being quiet or does nobody remember?
I don't remember.
Okay, one person doesn't remember. Thank you for answering.
Is it 4?
It is not 4. Nope. So how you can tell the separate branches is the vertical asymptote. The vertical asymptote is what divides it into branches, into pieces. So we have one vertical asymptote. There will be a piece on the left and a piece on the right. And I thought maybe you'd think there were 4 because we got kind of 4 quadrants kind of thing. There will be a piece on the left and a piece on the right. Now you can find additional points to be confident in your graph, but I'm going to be confident in myself right now that because there's a point near this asymptote and a point near this asymptote, it's going to look something like this. On the other side, I might find a few points. But that's also, I'm the teacher and have, taught this a few times. So on the left side of that line, we have found -2. How about somebody finds -3? Who's going to find -3? Okay. And then somebody else find -4. Who's going to find -4? You can't do all of them. Oh, I thought you did the first one. And then how about, oopsies, how about somebody finds what's a good one? -5. We'll just do those. Which one are you finding, Marie? You're doing 3? -3?
I'll do 3, I guess.
I'll pick one and find it. But Bryn, you got -3 for -3? Anybody else get that one done? Did you get -3, -3? Anybody get -4? Ooh, which one did you do, John? Okay, we'll pick one. I'm not making you do all of them right now.
Can you scroll up so I can see it since my Chromebook just died?
What are you trying to see? Oh, the equation.
Yeah.
Do you need to go get a Luna?
I'll do that after you're done.
I mean, this is pretty much it. So we're just going to find some points and connect them.
Well, my next class doesn't need a Chromebook, but I won't be able to do anything.
Right.
Okay. So, could I have a class, please?
You know what? I have a kid that has left his Chromebook charger here for 2 days. Why don't you just move right there and plug in? I forgot about that. I know. I even called him on Friday and was like, come get your Chromebook charger or you're not going to have it over the weekend. And he didn't come.
It's free real estate.
All right. Who did -4? What'd you get, John?
I did -5.
Oh, okay. I'll come back to you. Who did -4? What'd you get, Lydia? 14 over what? Did you guys get the same thing? 14 over 3? No? Oh, -14 over 3? Okay. And what is that? That's like 4 2/3. Okay, John, what'd you get for -5?
I got -6.
Oh, that's an easy one. Okay, so it appears that it is getting closer and closer to this asymptote, and it will always get closer and closer to the vertical asymptote. So that's got to be what this one looks like. How can we, after we've done our work, be sure and be confident that we did it right or find out that we made a mistake? You could use your graphing calculator or Desmos. Either of those will help you. But the majority of this you should be able to get without the use of a calculator. Okay, but some of these are funny looking. Some of them, I just know that some of them are tricky looking. So there was one example that I did not go over, and every year somebody's like, I don't know how to do this one. We did mention it a few times, but I didn't give you any examples of where it was like y = 0 for the horizontal asymptote, but I know there is some in the assignment, so just make sure you pay attention to those degrees. And you have about 15 minutes now to start it. And that's because we had a longer class than the other 2 bells today, but that's okay because my class tomorrow will have that full time. Then I